In this section, we want to look at being able to solve a logarithmic equation. So the basic steps that we kind of want to go through, we want to isolate the base or isolate that logarithmic function. Then we want to change the function from a logarithmic function into an exponential function using the properties that we looked at the other day of being an inverse. Right? Once we've done that, then we're going to be able to solve just like we did a regular exponential function. The only difference here is that we want to go back and make sure that we check our solution. So we want to plug our answer back into the original equation and just make sure that it equals the value it's supposed to. If it does not equal that value, then we would say there's no solution, and instead we have what we call an extraneous solution, meaning that when we solved it, we got an answer, but that answer does not check back out. All right, so let's try some. All right, so the first thing we want to do is isolate. This first equation is already isolated, meaning that the log is already by itself. Okay, if you look at, say, the second example, I have a +2 on the outside. If you look at the next one, I have a 4. So in our first example, the log is already isolated. So I'm going to move to my next step. The next step is that I want to change it from a log to an exponential. So remember, we looked at that the other day. We want to take this base of a 2, raise it to the third power, and it equals 2x plus 1. Remember, I take the base of the log, and then I'm going to switch those. All right? So now that I have changed it into an exponential, I can begin to solve it. So the way that I'm going to solve this, I'm going to first off say, well, 2 cubed, which is 8, equals 2x plus 1, and then I'm going to subtract that 1. Then I'm going to divide. You can leave it as a fraction or you can leave it as a decimal. It doesn't matter. I want to make sure that it works, so I'm going to go back up to my function here. I'll know that it works as long as the value that I get inside of every log is positive. So when I'm checking, I really want to check to make sure that I get a positive inside of each log. Okay, so if I do that, I'll come up here and I'm going to say 2 times 7 over 2 plus 1, and I do get a positive number, so therefore I can say that 7 over 2 is a solution. All right, so moving on to the second example, I want to isolate this log here, so I'm going to need to get rid of this +2. I'm going to subtract it on both sides. So I have my log base 3 x squared plus 1 equals now 2. So now I see that the log base 3 is isolated. So now I need to change this from a log into an exponential. So I'm going to take my base 3 and then I'm going to switch these. So it's going to be 3 squared equals x squared plus 1. So then I'm going to go ahead and solve here. 3 squared is 9. I'm going to move that 9 over. So I'm going to get x squared minus 8. And then I can keep solving. So I'm going to move the 8 over, take my square root. Remember, when I take the square root, get a positive and a negative of that value. So I get a positive square root 8 and a negative square root 8. Okay, so I want to make sure that they check out. So I'm going to go back up to my original log and make sure that I get a positive value. So when I square something, remember, I always get a positive. So I'm going to take a positive value and add 1. Both of these are going to give me a positive. So both of those will be a solution. Okay. All right, let's look at our next one here. I want to isolate this natural log. So to do that, I got to get rid of this 4. So I'm going to divide everything by 4 here. So now I've got natural log x minus 3 equals 3. Now that my natural log is by itself, I need to rewrite this. Remember, when there's nothing there on a natural log, there's an e. So I'm going to use my base of e, and I'm going to switch these. So e cubed equals x minus 3. Now e cubed, you're going to have to go into the calculator to get that value. So I'm going to get 20.1 equals x minus 3. Right, then I'm going to add that 3. So I get x equals 23.1. I want to make sure that that actually works out. So I'm going to take this back up to my original here. So 23.1 minus 3 is positive, so it will work. Right? Last one. I want to isolate this log. So to do that, I need to first add this 7. So I've got 2 log x plus 5 equals 4. Then I still need to divide by this 2. So I'm going to log x plus 5 equals 2. All right, now that the log is by itself, I'm going to switch it into an exponential. Remember, if there's no number there on a log, it's a 10. So I'm going to have 10 squared equals x plus 5. All right. Now, whenever I'm finishing solving here, I'm going to have 100 equals x plus 5. So I'm going to subtract that 5. So x is 95. I'm going to make sure that that works. So I'm going to go back up to my log and make sure that I get a positive number here. I do get a positive number, so 95 equals x. So remember, my steps, I'm going to isolate the log. All right, then I'm going to change it into an exponential. Then I'm going to solve it. I'm going to take that value back up into the log, and I'm checking for an extraneous solution, which means I'm going to check to make sure that I get a positive inside of each log that I have.